Right. I think it's working. Cool. All right. So this is Fighting Child Exploitation with Oculum, which is an open source tool to help law enforcement do good things to put bad people in bad places. So, let me turn this on first. So just very brief overview about who we are. So my name's Andrew Hay, CTO and co-founder at Leo Cybersecurity. Used to work at Data Gravity as a CISO before. Worked at OpenDNS. I was the director of research there. I've also worked at Cloud Passage. I was an industry analyst for what feels like forever, but it was only like 3 years. And worked as an information security officer in a university in Western Canada, in Lethbridge, Alberta. Does anyone know where that is? Really? Oh, you're the Canadian, that's right. Not fair. So it's an hour north of the Montana border in the middle of nowhere. I also worked at a bank in Bermuda, which also the middle of nowhere, but a different kind of middle of nowhere. Blogger, sometimes written 3 or 4 books that none of you have read, but that's cool. And fun fact about me, so I played rugby for about 20 years, and now I coach San Francisco's only gay rugby team. And usually when I say that, there's 2 things that pop into people's minds. One is there's gay rugby. Yes, there's a lot of gay rugby. And 2, why does San Francisco only have 1 gay rugby team? Well, they were the founders, or one of the original 3 teams in what is now the International Gay Rugby League. And in June, there's actually a huge international tournament in Amsterdam called the Bingham Cup, where everyone's flying to, except for me, because I'm not sitting on a plane for that long. And I can only take so much glitter and techno. So, with that, I'll hand it over to Mikhail.
Hi everyone, can everyone hear me? I would not want to meet you on the field. I'll get destroyed. So hi everyone, my name is Mikhail. I also work for Leo Cybersecurity. Andrew is my boss's boss. I am an architect and analyst. Basically, I wear many hats, do many things. I develop, I hunt, I hack, I research, I talk, and try to educate. So before this, my path into security actually does not go through the network and systems, as it's, I guess, a more usual case. I come from software development background. I used to be a .NET programmer. That's how I started years ago. And I'm very much into mathematics, cryptology. In fact, I taught a course in the cybersecurity program at St. Bonaventure University on crypto. I used to play pretty serious tennis until I finished college. I used to be a pretty hardcore gamer. I clocked so many hours in World of Warcraft that the game has a /played function that you can invoke, and it tells you exactly how much time you've spent playing the game. And I've stopped doing that. It's pretty depressing. Don't play much anymore. I kind of degraduated into bloody casual now. So yep, that's me.
And you have a girlfriend now, so that helps.
Yeah. There's that. Okay, back to you.
All right. So this project came to being mainly because when I was in Eastern Canada, in New Brunswick, I was a member of HTCIA, the High Tech Crime Investigations Association, I believe. That might be wrong. But apparently the office that was in Fredericton, New Brunswick was one of the core places where they did a lot of child exploitation cases. And in talking to some of the RCMP officers that worked there, they were on like a 6-month rotation because it was so traumatic in having to go through all these cases over and over and over again that they had to be rotated out because they just couldn't take it anymore. And many of these officers had kids, had families, and they would just get so mad and so disgusted that they'd have to take a leave of absence and go to therapy, and et cetera, et cetera. So just some stats. You may not be able to see this. So I pulled this from the National Center for Missing and Exploited Children. So 2012, Child Victim Identification Program reviewed and analyzed more than 80 million child pornography images since it was created. That's a lot. 25 million images are reviewed by NCMEC annually, so that's 480,769 images per week. And there's been a 774% increase in the number of child pornography images and videos reviewed through the NCMEC, which is horrific and a very arduous task. So, I'll skip over this one. Well, some of it. So I've done a lot of forensics and incident response work in the past, and I thought, okay, what is something that very poor law enforcement agencies just have to do as part of their regular course of being cops? And, what's a horrible thing that we can try and make a little bit easier? So came up with this idea, in part when I was sitting in an AWS presentation on Amazon recognition services. So being able to do that, to do photo identification, person identification, and then detect all sorts of different labels as they pertain to the image or the target. And I thought, you know what, this is something that law enforcement could probably use, and they're not going to want to pay for the privilege of doing so. So if we create a tool that allows them to do it, that's a step in the right direction. So one of the big problems, so I was involved in one child exploitation case when I worked at a university, and it was the kind of thing where an entire lab was put on a shipping pallet and brought down to my office. And the IT guy said, hey, we have a case of child exploitation material that someone left left a USB key in one of these systems and was distributing it over the course of a year and a half. We only found out because he left his key there and some good Samaritan turned it in at the security office, and the security guys plugged it in and said, oh my God, what the hell is this? Call the cops. So I had this pallet of 20 machines with images, because it's a university and it's a student lab, everyone's Facebook pictures, all of the cached images. So performing a forensic analysis across 20 machines, looking for illicit pornography as it pertains to that one individual, that was a hard task for one person in a 2-person information security shop for an 8,000 student university. So that was also the kind of, I thought, you know what? I don't want to go through every single Facebook image that is cached in this data set. I just want to know if there's really horrible stuff, then I can take that and give it to the cops. So there's, really the ultimate goal was determine the probability that visual content, both pictures and videos, contained illicit content as it pertained to child exploitation or child pornography. I'll kind of switch between CP and CE for the terms throughout this. But really what the tool is going to do, or does already, is allows people to take a look at those tags, narrow it down between, okay, this is just someone's family pictures, someone's in a bathing suit, there's some nudity or partial nudity, but it's a 40-year-old man and only a 40-year-old man, so we can skip over that. And we can take a look at this huge data set in one huge swath without having to go through each individual image, which is time consuming. So the other plan was, as the analyst or the forensic investigator was going through this process, they'd be able to create a hash of every file so that they could reference it and make sure that chain of custody flowed from the point they were investigating all the way through the analysis. And like I said at the beginning, we wanted to make good people's lives easier and bad people's lives absolutely miserable. So I'll hand it over to Mikhail for how we built it. Because, being CTO, I can go to Mikhail and say, hey, I've got a really cool idea that you should build something for me. Here's what I would like it to do. Go.
Test again. So when Andrew approached me with this idea, one of the first questions, as a developer, I try to work down each branch, think about everything right from the start, because that saves a lot of time. I try to never touch my keyboard until I am, in fact, already sure of exactly what I'm doing. I may not know, I may forget the syntaxes, I may forget exactly how to approach a particular algorithm, but usually when I start coding, I know exactly what I'm doing. So, as I started thinking about this, I asked Andrew one thing. I said something like, Andrew, how in the hell are we going to test this? I ain't looking at that. And so this one, he suggested that he has some friends in law enforcement, and potentially they would help us test, because I'm not looking at that stuff. So anyway, here's how we built it. As Andrew mentioned, we leveraged heavily Amazon Web Services. I'm just going to say AWS from this point. And so one of the issues that we encountered, and again, more details in just a little bit, but basic steps are you will take all the evil stuff, you will upload it to AWS. AWS will do some analysis for you. Oculum will do the rest, and then we'll tell you the probability that a particular image or video file contains some evil. And so it's kind of amazing that like having to work on this kind of stuff makes you realize that humans are incredibly brilliant and also are capable of some pretty screwed up stuff. So I think I'm going to be coming back to this slide a few times. Can I have a clicky thingy? Yeah, so how exactly do we upload? Oh yeah, so what is Oculum? Oculum is nothing more than a Python script. It's actually quite basic. I mean, right now it's about 500 lines or so of Python. Why did we choose Python? I was tossing idea in my head about developing in Java, but I was very quickly told to go stand in the fire. A big one.
And do you want to know why I told you that? So I've written a bunch of forensic tools in Ruby, and I would present them to my forensic friends, and they said, hey, that's really awesome. Too bad we will never use it because it's written in Ruby. I'm like, oh, thanks, guys. Screw you. I'm not developing anything anymore. So in forensics and incident response circles, if it's not in Python or Go, you're probably wasting your time. You're not going to get any sort of attachment from the greater community for these tools. And I dare you to do something in Perl in this day and age. So I think that'd be adorable.
I think we have a couple minutes for a programming language joke. People like memes here? Anyone like memes? It's not quite a meme, but it's a cartoon, and I'm sure you've seen it. It's like something about in different programming languages, how do you write an essay? And there are a comparison of about 10 languages. In C, the professor reads the essay written in C, and he like wipes a tear and goes, "This is the most beautiful thing I have ever read, but you forgot to terminate with byte 00, and I'm just reading garbage from your memory on the stack." In Java, it was something like, "I am 10 pages in, and I still have no idea what the heck you're saying." And in Python, of course, it was, you can't just import essay. That's plagiarism. But yeah, so Python, it's all we work at Leo, all we try to is incredibly easy. So this is a Python script, like I said, about 500 lines. This is the screenshot of /h, so this is your typical help thing. As you can see, it doesn't do terribly much. It does what it was designed to do, and only that. So I think we will go through these instructions just a little bit later, but it allows you to set up the instance on your computer. And of course, well, you all know Python can run on any platform because it's not really running on any hardware. It's running in the virtual environment. I think I'll be coming back to this. So how do you upload? How do you store? Oculum leverages Amazon's AWS's S3 buckets. If you don't know what those are, they're basically containers on your AWS account, and you're able to just upload things keyed with a certain name. Cannot duplicate that. And so an important part there is that, wait, did I skip this? Oh, no, I didn't. Right. So Oculum leverages the Bodo 3 API, like in the picture here. How do you do the pointer? Oh, there's. So this Python is basically Oculum. This is AWS infrastructure, and this Bodo 3 is the API library that all this is done with. And it's, I got to tell you, it's incredibly easy to code. Didn't take me much time at all, just handling all the exceptions and stuff. So one of the things to note is that recognition is not available on all AWS regions. So these are the only regions where it's available, and I'm sure they'll expand. But at this point, you in fact are restricted to these regions. If you're wondering what this last one is, it's actually a region for all the governmental services. So for S3 buckets, again, what a bucket is simply a container in AWS where you dump your files. And if we go one back here, so here are a couple of commands, right? So the setup command we'll show you in a little bit. And so the list buckets, it lists your buckets. If you don't have any, then you get an empty list. You can list regions. You can list files within a bucket. So how you start actually working in Oculum is you do this create bucket command. And again, all examples are in just a little bit. So again, with buckets, you can list them, you can create them, and you can delete them. I didn't do too much itemizing as far as like how you delete files. I currently wrote just that you can delete one file or you can delete all files, but you can't like delete files A, B, and then file X, Y, Z. And file operations, you have to specify a bucket where you're uploading. You can either upload a single file, you can upload an entire directory from your local machine. Of course, like Andrew is saying, if you have like thousands of files, you don't want to be doing it one by one, right? And then, of course, you can delete one file or delete the entire bucket. So what does Oculum leverage? This AWS recognition is, I think all the big guys, they have some kind of face recognition software. I think Microsoft does something with Azure in the cloud, but so recognition is Amazon's thing, and it works pretty darn well. So a couple of things we leverage in Oculum. So first of all, we have this general label recognition. And that actually doesn't give us too much. It is too general to be used in any kind of statistical test. All it can tell you is whether it's a man or a boy, woman or a girl. And again, sorry, it's kind of hard to talk about this stuff. I know we're talking about great evil here. But it can only tell you with a certain probability of what are overall objects that it's seeing. So for example, what I'm seeing right now, all of you, it would return maybe light, people, one person, many people, tables, chairs, things like that. So more to the point, it has actually detect moderation labels, and it has a couple of categories. There's suggestive and there's explicit nudity. Suggestive, all it means is that there's no quite nudity per se, but it can be, like Andrew was saying, it can be a picture on the beach, body partially exposed. Well, again, don't want to get into too many details. I mean, you understand, right? And so one of the downsides is that unfortunately it cannot, when it says that it's an explicit nudity in the image, that does not tell you how old the people are. And you have to leverage this other thing, the detect faces. So one downside of Oculum right now is that there indeed need to be faces in the image. If there are no faces, it does not work because recognition needs faces to determine ages. And it's fairly accurate at doing that. And I'll tell you our algorithm in just a little bit. Again, keep in mind that this is a very young product and we kind of stopped development. We'll get into this in just a little bit, but the algorithm is nothing fancy. In the long run, we're definitely going to do something with machine learning, and don't get me started on machine learning. It's stats 101. Seriously, it's statistics 101. You can't get simpler than that.
Or add some AI, too.
Yeah, AI goes in the same bucket.
Put it in the cloud and then raise $40 million for the startup.
And so, for instance, if you submitted a picture of a boy, and it would tell you, okay, it will give you a low and a high estimate of what recognition thinks, what is the low versus the high age, and so it falls somewhere in between. And then it will tell you, okay, I'm 90% sure in my answer. So it's pretty good that it not only gives you those low and high boundaries, it also tells you how sure it is, and we see how we leverage this. So yeah, and the downside is there needs to be faces, otherwise it's going to be a negative identifier. So it's a really cool looking point in the face there. So there are several weights that we use, and here's where we get into the actual algorithm that we use. So we are using, so these two weights are ours, it's Oculum, and this one, this is a very important thing. So not only does recognition tell you, okay, I think there is explicit nudity in this image, it also tells you the probability that it thinks it's correct, and that's actually an important number. So that's one of the gears. And then we have to ascertain what we think is the youngest person in the image, because we don't care about anyone but the youngest. Because even if there are 100 people that are 21 and over, if it's an explicit nudity image and there is a 10-year-old, that's all we're interested in. And you'll see how the algorithm does that pretty easily. So this is a very important point in the algorithm right now. We are discarding anything where Amazon is not over 75% sure. And there will be an example where we get into that. So if Amazon does not say that there's explicit nudity with at least 75% probability, the result is for our algorithm is going to be 0, and you will see that. This is an algorithm thing. So this is a for loop, if you know anything about coding, and this is the if condition. So if the Amazon says, okay, there is explicit nudity, I'm fairly sure more than 75%, we'll calculate the average of the low and the high age, right, with that probability. And then so this approximate youngest age is what we're interested in, not what goes into the actual calculation of our score. And now if this condition is met, if it is now younger than our current average, we swap that. Let's go here. Okay, so back to this one. So once after this loop, we define what is in fact the approximate youngest person in the image, we go to this part of the algorithm, and we simply apply some dumb weights. And currently there is no AI, and I simply did some averages. So I said that, you know what, if Amazon is pretty sure that the youngest one is between like 0 and 12 years old, I set the confidence at 100%. Because if it thinks it's 12 and under, we can be pretty darn certain that at least it's something to look at. And it goes all the way to, like, there's a 12 to 13, 13 to 14, a lot of buckets. Probably shouldn't use the word bucket, because don't confuse with S3 buckets. But ultimately it stops at age 19 or 20, and then the confidence is only about 30%. And the actual score that we compute is very simple. This is what comes from Amazon. So that's when Amazon said there is explicit nudity with a probability of 90%. And we multiply that with this underage confidence, which we set right here. So basically, if this ends up being 0, or if this ends up being 0, it returns 0, as you will see in the examples. That's just a screenshot of the code itself. I mean, it's just basic Python. This is the buckets that as I was describing them. So you go from 0 to 12, you got 1.0, the absolute probability, and all the way here is you have 0.3, and they decrease. So why did we do this? Is because obviously some kids, they can be 21 and they look like they're 15. Some kids can be 15 and they look like I think I stopped getting ID'd when I was like 20. Oh wait, no, 21. Gotcha. All right, I spent some time in Canada. Okay, so yeah, just a screenshot of the code. So here's an example of how you would set this up. You would just run Python Oculum setup. You do have to have AWS account, and you do have to set up your API key, because that's how it does API calls with AWS recognition. So if you answer either, sorry about that. If you answer either no here or no here, it's going to just give you a friendly link saying, go do these steps and come back when you have an account and an API key. Once you say yes, yes, it asks you to get the actual ID. It asks you for your secret. Of course, it's not gonna recall it back to the screen. And it does ask you for the default, for the, what is it called? The default region, because again, recognition only works in certain regions for now. And then it says setup complete. This example is for the upload. Like I said, upload begins, you will need to create bucket first. So you invoke that just by create bucket. You specify the bucket name. In this case, it's Andrew Hay here. You specify the region, create the bucket, and then what he did here, he did a multiple upload. Now if I go all the way back to the listing of commands, what happened? Okay. So you'll see when you You can upload file, which uploads a single file. You put file path and bucket name. And what he did upload multi, which you specify a directory. It loops through every file in the directory and uploads all the JPG and PNG files currently. So that's what he did. That's what he did here, and for each file you have a nice little progress that keep printing out, and then when you're done, it says when you're done. If you are uploading, say, 100 files, it probably will take you a few minutes, depending on their size.
If anyone's wondering, the images that are there, I went to Wikipedia and typed in girl and boy, and then it had various ages of kids from a newborn all the way up to, I think, 20. So I just use those because that's safe.
And I didn't look at it, and I just said, okay, here's the code, you do your testing. Okay, and here what he did is the actual score. You'll see it returns 0.0% because, again, we weren't testing with any of the real stuff. Andrew will tell you some fun facts next, I think. Oh yeah, so these are the overall labels that you can request for any image that you uploaded, and as I said before, this is not quite precise. So you will see here that sometimes Amazon gets confused. So here you'll see girl and woman share the same probability. So this is where it's in fact not sure how old the person was, and but you do see here that it is about half certain that there is a child or a baby or a kid. That's how it does. But this is not something we rely on. You can simply request the labels. And this is where you can request, we call them the X labels, but what it's doing, it gives you the probability whether it thinks an image can be suggestive or there's explicit nudity with certain probability. So that's what that picture, and again, he has, yep.
Yeah, that picture was a newborn, like freshly delivered baby with the umbilical cord still attached. And it showed that was the probability of explicit nudity and graphic female nudity that came up.
Right. And this is exactly why we're doing 75% or greater, because that would be a false positive. And we want to reduce the number of false positive, of course. And again, this entire algorithm, like it's not tested. And Andrew will get into this next. We kind of halted development on this, and it's still in its very early stages. I mean, eventually what I wanted to do was to start auto-tuning each one of those 3 gears and do like an automatic feedback loop where the system would be able to modify itself to give you better probabilities. So machine learning or statistics 101, basically. And if when you're done with a particular case, you can delete the whole bucket, or you can delete a single image from the bucket. By deleting the bucket first, it goes through the loop, it dumps all the files out of the bucket, terminates those, and then kills your bucket for you. Okay, now back to Andrew with some of the troubles we encountered. Oh, there you go.
All right, so now that we have a basic framework, we thought, hey, let's share this with some trusted people in the law enforcement community that work on cases like this. So some of them wanted some information. No one really wanted to test it because no one wants to be on the hook for testing something in their already stretched thin workday. And I did get one of my friends who is law enforcement in Texas, who, he is a coder, he's written books. I figured if anyone, he would be like the absolute highest level of individual in terms of technical know-how that could go through this without guided instruction. And he said very point blank that exact thing, that, you need something point and click if you want cops to use it. So then we got on the phone, and that's where things kind of went bad.
Hang on, before you get into that. So, again, this was just proof of concept, but there was a reason that we did not do a graphical user interface, because one of the main points of the system is that for people to not see those kinds of things. So that's why we left it right now at a command line. Yeah.
So, in case you didn't know, uploading of child exploitation content, it's illegal. And this is what my friend told me on the phone. Also, if you upload illicit child pornography to AWS, to Azure, to Google, so you're committing a felony, just so you know, and the cloud provider is actively checking these pictures and will rat you out to the proper authorities. So even if you're trying to do good, they're not happy with you because you could be just some deadbeat who is uploading illicit content, and they want to make sure that you don't do it anymore. And eventually someone's going to show up and educate you as to why what you did was a bad thing. So then I asked him, I'm like, well, can't you test like in your environment? And then he said something to me that kind of made me laugh. He's like, so you're worried about committing a felony and you'd like me to commit a felony on your behalf? I'm like, yeah, Nick, that would be great. Could you do that for me? He's like, no, I don't think I'm going to do that. All right, that's fair. So then I started thinking, and then we started thinking, could we test this? And here's the problem. I'm Canadian, he's Russian. It would not end well for us. So, not only do we not want to test it, but we do not want to be the ones associated with the testing.
No. Uncle Sam will come.
Yeah. And I'm honestly worried that we'd end up in like Guatemala or something, because nobody knows where Canada is, or Russia. So, some of the things we learned, and it's not a complete showstopper, but it's kind of a, okay, let's pump the brakes and get some more clarification before we proceed. So AWS has this thing called, or that they align with the FBI's Criminal Justice Information Services Standard. So it's just like being SOC 2, PCI compliant. You have to adhere to the rigor set forth in this standard, and your state has to comply and has to certify that it can interoperate with your platform as it aligns with this CJIS standard. So you'd think you could just go and say, okay, show me all of the states and cities and townships in North America that comply with this. Oh no, you can't get that. You could probably pick up the phone and try and get through first, second, or third tier support, but it wasn't posted on the website.
Yeah, it's not readily available at all.
Yeah. But there is a blog, so if you fetch all the titles and start indexing everything, you can figure out who can use it. Because really, it's a state level issue at that point. And the majority of these, you can do forensics in cloud environments, most of which for law enforcement is done in the Gov cloud because it's safe and secure, right? Compared to every other cloud. So,
and even though I showed you that one of the regions was government, the way AWS S3 buckets work, that's absolutely not the same thing. So that would not be enough at all.
So some of the things that we learned, and I actually knew this from OpenDNS because we worked with one organization that would give us indicators of known IPs and domains of either under investigation sites or distribution sites. And you can go to these same organizations and say, hey, we want to help you fight the good fight. Can you give us access to your hash database? We're two people. We're not their target audience. So they are not going to, we just can't go and say, hey, can you give us access? Because they're not going to acquiesce to that request. Because there would be a lot of due diligence on their part to make sure that we weren't just two pervs that were trying to get around what they're checking for. And AWS subscribes to this same service. So they get all of the information. And because we are not a law enforcement agency, even if we were uploading this, again, Canadian, Russian, be on the next plane somewhere. And if we want to be taken seriously, and this is straight from law enforcement, we need that tight integration with those closed environments. And that's, we don't have a lot of time. We have day jobs. We wanted to do something that would help people. So at least we have a framework that as organizations or as law enforcement evolves and some of the cloud technologies and rigor is ironed out, there's not a lot more that we can do because, again, we can't test it and we're not going to test it.
Yeah, and what they told us, the only way it can be usable now is that if it's completely run locally. So if we develop a tool, so artificial intelligence, that can do all that stuff that Amazon Recognition can do locally, then that would be completely usable and they wouldn't be in violation of any of the laws and regulations. I don't think I quite suck as a developer, but
you can't build
that
AWS.
is, hats off to people who dabble in those things. I looked at some white papers and I looked into like how it's done and what sort of algorithms they run. Yeah, no, not anytime soon. I'm quite limited at this point. Although that would be pretty cool research, but busy with other stuff. Like I said, many hats.
Local law enforcement still relies on those local tools, and they will use it if it's local. They will test it if it runs local in their sandbox. But unfortunately, cloud doesn't really work that way. So in summary, so you can use all the various clouds to do this image recognition and information gathering. Oh, that's you because your mic's on. Oh, there we go. All right. Must have been Adrian because he walked in here, did something and left. So yeah, you can use all the cloud providers to do this image recognition. And there's still a lot of value in being able to do this for large data sets or large sets of image data and video data. For example, if you know someone that you're looking for across a huge bucket of images, it's very easy to say, this is what the target looks like. Show me the probability that this is going to exist in all of these different files. Very easy to modify the code to do that. We wanted to help law enforcement so that they didn't have to look at terrible things as frequently. And, we can't help them with the red tape. We can't help them get out of their own way. And it's not law enforcement, it's, state, local, federal government that's really slowing things up. So really, we're releasing the code in the hopes that things get better. And, we'll probably poke at this from time to time when we have some downtime, maybe add some additional features. And I encourage all of you, if you want to do that, go fork the repo and make changes, submit comments. If you want to test it with some of your data sets, not necessarily having to be child exploitation. It's also a good framework if you want to learn how to use the API to work with recognition and even uploading, downloading, deleting from S3.
So another few things I want to say just about development process. So one of the difficulties about utilizing something like AWS recognition, say if I write an algorithm for, say, facial recognition, I know exactly what it's doing. So to minimize when the product is ready, if it's ever ready, to minimize the rate of false positives, the thing with machine learning, I'm sure you all know, it's not magical. And it follows a very strict paradigm of garbage in, garbage out. First of all, machine learning is all statistics, and any statistical model, even good ones, even the best ones, they only ever work if it's implemented properly. So one of the downsides of using some provider like AWS is, as a developer of Oculum, I don't know what they do. And say if a particular circumstance occurs where I need to troubleshoot something, and I would be wondering, so why did Amazon return 74% sure and not 75? I don't know. And as a developer, it's quite a nightmare not knowing what you're depending on. It's like when you're trying to import a closed source library or some kind of an executable, and you have no, unless you want to reverse engineer it, you have no real way into it. It's quite a hurdle. But yeah, like I said, at this point, I'm not about to write something like that.
So parting words, always look at the laws for whatever it is you're trying to do with your code. And ideally, you want to do that before you start building the tool. Even better if you do it before you finish the tool and want to have people QA it. So with that, if you have any questions, you can ask them now. We're going to be around today, tomorrow, for a bit. Yeah. Yes, sir. Yeah, oh yeah, you. Why wouldn't they? It would probably be a resourcing issue. Like, I haven't talked to anyone in the FBI. I guess I could, so I'm on a bunch of closed networking groups of threat hunters, incident responders, and I blasted out the email, and there's thousands of people on this. I'm like, hey, we've got this tool, it's going to do this, that, and the other thing. Does anyone want to try it? I got one response. And it was from a consultant that consults with the police service in Madrid. So it wasn't really my target demographic because it's not really going to work that well for them. So yeah, we could, I'd be happy to talk to the FBI and collaborate with them and say, hey, take our code, do something with it.
And also, like, one of the reasons we bring it out is that it will be hopefully much easier to do things like that in the future. Yeah.
Any other questions?